So I hope that you've seen, working through our solubility problems, that so many of these solubility or problems we've actually already seen as equilibrium problems. We're just applying them to a new system. We've learned how to write equilibrium expressions in type 1 and type 2 problems to calculate K or use K to determine equilibrium concentrations. We've thought about how common ions affect equilibria and predicted how adding a product or removing a product will affect equilibria. The next problem looks at predicting whether a precipitate will form. And really, this is just a version of Q versus K. If we want to predict whether an equilibrium or a precipitate will form, we really have to ask ourselves, which side of the equilibrium are we on? So let's actually think of this problem and see if that makes sense. So if we want to think about whether or not precipitate forms, we have to ask who's in solution and then ask, have we reached kind of a critical concentration that's above and beyond what's allowed to be in solution? And if that's the case, we'll have some precipitation. All right, so this was actually a problem that I gave as a version of on the quiz, and I think a lot of people got confused because there was a lot of ions in solution. So the first thing you should always do, just like we did with titration problems, was just ask who's in solution, and then what you'll see here is there's a lot of members of solution that we really don't need to worry about. So who's in solution? Well, we've got calcium nitrate, which really all nitrate salts are soluble. So that breaks apart to calcium ions and 2 nitrate ions. Nitrate ions are not anything we're worried about. Nitrate ions are always spectator ions. So from our calcium nitrate solution, we really only have calcium ions. So we had 0.3 molar, and we had 100 milliliters of that solution. So that's kind of what's in one flask. So I'm going to kind of draw a little picture down here to help us understand what's going on. So we've got one flask that's down here that has 100 milliliters in it. And for all intents and purposes, what we really have is 0.3 molar calcium 2+. So that's kind of flask 1. We've got flask 2 that's got sodium fluoride. So sodium fluoride. You need to remember that all sodium salts are soluble. So we're going to make the sodium cation and then the fluoride anion. Okay. Sodium, again, is going to be a spectator. We're not concerned about anything that might contribute to solution. So sodium fluoride here, we've got a 0.06 molar solution of sodium fluoride, and then we have 200 milliliters of it. So here again is flask 2. So flask 2 is going to have 200 milliliters in it. It's going to have 0.06 molar, and the only ion in it that we're concerned about is F-. So what really happens here is we mix these two solutions together. So we're going to have a total of a 300 milliliter solution, and there's going to be calcium ions there, and there's going to be fluoride ions that are there. And the big question is, are these concentrations such that we've exceeded the maximum amount? So what we really need to do is we need to find the concentration of calcium after we've mixed, and we need to find the concentration of fluoride after we've mixed, and then we need to use these to figure out Q. Where are we at? And we need to compare that to K. Where are we allowed to be? And ask, is Q greater than K or is Q less than K? So let's again make an equation to kind of think about what's going on here, right? The equation would be, these guys are spectator ions. The only things that would be in solution that could possibly have any chemistry are calcium ions and fluoride ions. And so even though we're talking about the two of these reacting and coming together, I'm going to write this equilibrium the way we usually see slightly soluble compound equilibria, which is drawing the solid on the left, okay, making calcium ions and fluoride ions. So again, the question is, are the concentrations of what we have after we mix these such that we've exceeded the maximum allowable amount? So we need to kind of do a Q versus K comparison. So KSP is again equal to calcium concentration times the fluoride concentration squared. And we can look up what that value is from our appendix. From our appendix C, we can look up the KSP value, and that's going to be 3.2 times 10 to the minus 11th. Now, if we treated this with an ice table and we got an X and a 2X for this, we could solve for kind of what the calcium concentration could be and then twice that for the fluoride. But that's not necessarily what we have here. We're not going to have necessarily a 2-to-1 ratio here because they come from two different solutions where the ions are totally soluble because they came from totally soluble salts, and we're mixing them together. All right, so let's go through and let's actually figure out what our concentration of calcium is after we've mixed. So again, here's how we do that. We have to figure out how many moles we had initially and then divide by the new volume after we've mixed them together. So how to figure out how many moles we had initially was you had 3 moles of calcium nitrate per liter, and we had 100 milliliters. One of the things that mathematically it's not going to matter for this, but I want you to think about this because you might see a problem where it does. 1 mole of calcium nitrate gives us 1 mole of calcium. And I need to divide by the total volume that we have after we mix them, which is 300 milliliters. So this tells me that the new concentration of calcium after I mix everything together is 0.1 molar. Do the same thing for the concentration of fluoride after we mix stuff. Initial concentration of sodium fluoride was 0.06 moles per liter. We had 200 milliliters of it. Again, mathematically, this won't matter, but I want you to get in the habit of doing it because you might see a problem where it does. Divide by the new volume that we have. We've got 0.012 molar F minus. What we need to do now is we need to take these two concentrations and put them into our KSP expression. Okay, so we need to figure out our QSP. So that means taking the calcium concentration, which is 0.1 molar, multiplying it by the fluoride concentration, which is 0.012 molar, which that's squared, and figure out where we're at. So go ahead and do that, and you get 1.6 times 10 to the minus 4th. This is greater than the KSP. KSP was 3.2 times 10 to the minus 11th. We have exceeded the allowable maximum amount for these ion concentrations, and so we will see a precipitate form. Okay, so one of the things to kind of point out from this problem and just kind of remind everybody, look at the concentrations that we have of these two species. So again, this guy was the calcium ion concentration, this guy was the fluoride concentration. These are certainly not in a 2-to-1 ratio, okay? This is just kind of where we're at. What are the concentrations that we have? We didn't, like we saw with some previous problems, start with a pure solution of something and then ask how much could break apart, where we will get kind of predictable ratios of the ions. We kind of came about this problem from the opposite side, where we had these two ions completely soluble because they came from soluble salts, and we mixed them together. And then we said, once these guys are in solution, have they exceeded their maximum amount? And going through our calculation here, we see that they do, and we will form a precipitate.